Hi, grade 9s. Welcome to 7.3, which is similar polygons. You might remember from our polynomials unit, poly meant many. and excuse me, a gon is basically just a side. So polygons just means a many-sided object or multiple-sided object, like like a triangle or a square or a rectangle or a hexagon or a heptagon or a dodecagon or a googolcon. Similar polygons. We're going to be looking at polygons that are different, have different lengths on the sides, but have all of the same angles. And we're going to try and identify the scale factors involved in either reducing or enlarging a polygon, as well as determining side lengths when they give us information such as the angles or the lengths of certain similar polygons. So we'll just go through a few examples of these, and hopefully that will be a little bit more clear. Similar polygons have the same shape, but not necessarily the same size. So if we look at the shape down below, and this could be any shape, it doesn't have to be, this sort of odd five-sided figure. It could have been a square or a triangle, a couple of triangles, or a couple of hexagons. But if you look at this, both of these pentagons, penta meaning five, so five sides, you'll notice that the angles, first off, they look the same. The one on the left looks smaller, but they look the same. Secondly, you'll notice that the angles that look to be the same on each drawing are indeed exactly the same. So for instance, angle Q is the same as angle Q prime. That should be another point here. So if if the Q usually refers to the original, right? Not necessarily Q, but just for dealing with sides. This would be the new one when it's got that little thing up there, that little apostrophe, and it's usually referred to as, we would say Q prime. That's how you refer to that little apostrophe looking thing. And basically what it's telling you is you want to use the same letter because really it is the same shape. It's just not the same size. So we want to make sure that we identify that if this corner over here is Q, obviously just looking at the shape, this would be the one that corresponds to that. So we can't call it Q because Q would be this one over here. So we have to call it something different, but similar, which was Q prime. So this would be R prime and S prime and T prime. And we just do that so that it's easier for us to kind of go back to the other object and say, well, that must be this corner. And if I'm looking at this and I look at the bigger object, well, that must be this corner here. So that's why you see it written like that. In any case, we notice that all the interior angles on these two shapes are the same, but the lengths are not the same. So if we look at the distance between RS, it's 2.5 centimeters, and we look at the distance between R prime and S prime, and it's 3.75. So they're not equal, but we can say they're similar. If they were equal, they'd have all the same shapes. When we have objects or polygons with matching interior angles, we say that the angles are corresponding angles. And corresponding is essentially just communication. If you're corresponding with someone, you're communicating with them. So that's just kind of a fancy mathy way of saying this angle here is communicating with this angle here, and they're the same. So we would refer to those as corresponding angles. Matching sides are predictably enough corresponding sides. And again, this is just sort of help us keep track of what was the original and then what's the enlargement. And it's pretty clear when you look at the shape of these two objects that if I was going to say find the similar side, you would recognize ST as being similar to S prime T prime. You would recognize QR as being similar to Q prime R prime, just from looking at it in the shape of the thing. So these are corresponding angles and corresponding sides. Now you notice the corresponding angles always have to be equal. Okay, so these are always equal. Spell equal correctly. And corresponding sides are often different. So let's look down here. We've got the original versus the new one, or the enlargement. In this case, it says PQ is 2 centimeters and P prime Q prime is 3. So PQ is right here from P to Q. That's 2, and then the corresponding would be P prime to Q prime, which is 3. So those are corresponding sides, but they are different measurements. Let's look at the corresponding angles. You'll notice that angle P down here in the corner is a right angle. It's 90 degrees. And angle P prime is also 90 degrees. And you'll find the same thing with all of the other interior angles. So if angle R is 96, that means that angle R prime has to be 96 degrees as well. And if angle S is 110, then we know that angle S prime must also equal 110. So it's usually pretty easy to fill out the corresponding angles because they are always equal. It's when you have to look at the lengths of corresponding sides that things get a little bit more difficult because they are going to be different. So we're going to have to set up some ratios to help us out with that. All this middle column here is proving is what the scale factor is. Because remember, if we were looking at the scale factor, we've got the new over the original, right? So if the new is 3 centimeters for this side, and the original is 2 centimeters, we know we can divide those and get a scale factor. So the scale factor for the larger or newer object is 1.5, and this would be 1, right? So this is the original, this is 1.5 scale factor, which is just another way of saying this one is 1.5 times bigger, this is 150% of the original, things like that. But the scale factor is 1.5, and you should find that with all of the corresponding sides. So for instance, I may not have room for it here, but the new over the original here would be 3.75 divided by 2.5, and that has to be 1.5. If it's not 1.5, then these objects are not similar. Same thing here, it's the exact same measurement as well. 3.75 divided by 2.5 needs to equal 1.5. So if you don't believe me, you can get your calculator out. But that scale factor always has to be the same. If you get a different number on any of these, double check it and make sure that you didn't make a mistake in your math. Because if even one of these is not 1.5, if one of these was 2.1, for instance, it would mean that they're not actually similar objects and the shape should be slightly different. Probably different enough that you would notice it. So how do we define what a similar polygon is? Okay. What we say is, well, all the interior angles must be equal. So that's this part over here. And, Frank, they must have the same number of sides. They must look the same. But the official definition is that all the corresponding angles must be equal and the corresponding sides must be proportional. So a proportion is just a fraction, okay? Or a ratio, sometimes you see it written as. And what that means is if you take one side, okay, if you take one side of the new and one side of the old, okay, you should be able to set up a system where you've got two fractions and an equal sign. So it's an equivalent fraction, and we call this a proportion, or you can also call it a ratio, but it uses fractions. So I guess the easiest way to describe this is that the scale factor must be the same on both sides. Remember, everything up here had to equal 1.5 for a scale factor, and that's how we could tell that all the sides were proportional. They weren't equal, because if they were equal, they'd have the same measurement, but they're proportional, and that portion is always 1.5. So basically, the scale factor has to be the same, okay, on both sides. So a scale factor has to be the same as the other scale factor. And the way we're going to do that is with the same way that we figured out scale factor before. We're going to take one side and we're going to look at the new length, and we're going to compare it to the original length, and then we're going to do the same thing on the other side with a different length of the object. So that'll make a little bit more sense when we start plugging numbers in. So let's look at this side as PQ and P prime Q. Okay. And then on the other side, we'll use for a comparison, we'll use a different side. So we'll use maybe QR and Q prime R prime. So let's plug some numbers in and see what we get. We always got to start with the new. So if we're looking at the new, the PQ and the new, so up here, this would be PQ right here, P prime Q and PQ. We got to start with the new, which is P prime Q prime, which is 3 centimeters. So this would be 3 centimeters on top, the denominator, or sorry, the numerator, and then the original was 2 centimeters. And then we know on the other side of the equal sign, we're going to look at QR and Q prime R. So looking up here, Q prime R prime is 2.25 centimeters, so that's what will go on the top. And then for the original, QR is 1.5. And you know, this chart, this comes directly from here. So we're looking at this side right here, 2.25 and 1.5. So those have to be equal. Otherwise, it's not a proportion, or it's not, they don't have the same proportion. Therefore, those particular sides are not proportional. So if we're going to divide 3 divided by 2, you'll find that that's 1.5. And you'll also find if you divide 2.25 by 1.5, it also equals 1.5. So what we're saying there is we tested side PQ and side P prime Q prime and found out that the scale factor was 1.5. And we also tested out QR and Q prime R prime, and we found that that was 1.5. So we know that both, we didn't check all the sides, but we checked this side right here, and we also checked this side right here, and we found for both of those, they were indeed proportional, and they were, the scale factor for both of them was 1.5. So already we can determine that because the interior angles are all equal, and 2 of these sides are proportional, we're in pretty good shape for saying that these 2 are similar. So their corresponding sides all have to be proportional, and their corresponding sides angles have to be equal. And again, it's really easy to tell if the corresponding angles are equal, but you might have to do a little math to check the corresponding sides. So that's basically just the conclusion that we came to on the other page, right? The angles are all the same, and this is how you show similar angles. This particular arc in the A corner here is the same as the arc in the P here, and then you've got a little star in the C corner. It's the same as the stars in the R corner. It's just trying to show you which angles are which angles are corresponding. So all of the interior angles on these, they're quadrilateral, so they're 4-sided shapes. These are not the same shapes as the one we looked at above. These are 2 different shapes, but they are similar because this angle B corresponds to Q. There's 2 of these arcs, which says that that's the same angle. We know that A corresponds with P, and D corresponds with S, and C corresponds with R. So all the angles are equal. That was the first part of it. And now we had to check, are the proportions the same? So the AB on this one, this time, this would be the original, and this one would be the new, because we always write this as the new over the original. So if AB is on top, that means AB must be part of the new shape, right? So really, if this was the original, this would have been a reduction, okay, because this is bigger than this. So we would start with the one on the right, and then you have to make the one on the left, which is a reduction. And we can find out what the scale factor is of this really easily. Let's just do AB divided by PQ. So AB is 1.5 centimeters, and then, so this was AB, and then what was the corresponding side to AB would be PQ, right? And PQ is 2.1 centimeters. So we're going to get a number less than 1, which we should, because a reduction is supposed to be a scale factor of less than 1. And in this case, if we do 1.5 divided by 2.1, our scale factor is 0.71. So that would be a scale factor. So 0.71 is AB over PQ. Now, every single one of these other fractions deals with the other 3 sides of the object, and they all have to be 0.712. So let's just check, maybe let's check dA over CP. So dA and SP, sorry, SP. So what's dA? dA is from there to there, which is 2 over SP. So SP is 2.8. So if we've done this correctly, I'll just move this scale factor over a little bit. If I've done this correctly, or if these 2 shapes are indeed similar, this needs to equal 0.71. Otherwise, we could draw a conclusion that they're not actually similar. So 2 divided by 2.8 is indeed the exact same 0.71. So these are both the scale factor, right? And if we did the same thing with CD over RS or BC over RQ, we would get 0.71 all the time. So if all the interior angles are the same, and all of these ratios are the same, or all of these fractions are the same, because that's the scale factor, then we can conclude that these two shapes are indeed similar. Not equal, but similar. This says identify pairs of similar triangle, or rectangles rather, justify the answer. So now we know how to identify similar polygons. They don't actually give us the angles, but they do say that they're rectangles. And by definition, rectangles have 90-degree angles in every corner. So the first part out of it, where your interior angles must be the same, okay, well, the interior angles, so there's sort of the first note here, is interior angles are all 90 degrees. So that's the first part. They're all similar so far because all of the internal angles or interior angles on all three of these rectangles are 90 degrees. So now we got to check the sides. Okay, we got to check the sides. Now I'm going to number these rectangles just to make it a little easier for me to tell. So I'm going to label them 1, 2, and 3. And we're going to have to check them. All right, so let's check if we're going to look at similar sides. Well, there's length and there's widths for both of these. So I'm going to consider this top part and this top part and this part over here. Those are the sides I'm going to look at first. So let's look at the ratio between 1 and 2 and 3. All right? And then let's also pick a width. So we'll take this width, which would be those ones. And it doesn't really matter which if you took top or bottom because they're going to be the same. So if we're going to try to find out which of these are similar, okay, we need to create some fractions. Some fractions to help us out. So let's look at number 1 over number 2. At this point, it doesn't matter which one's new and which one's original. Okay, we just need to compare the side lengths for each of these rectangles. So number 1, 8.5 centimeters for AB. Okay. And then on the bottom, we've got 8.4 centimeters. Okay. So that's going to give us a scale factor, if these are indeed similar, a scale factor of 8.5 divided by 8.4, scale factor of 1.01, and then I'm going to round it, 1.012. So that would be a scale factor between object number 1 and object number 2. In this case, object number 1 is bigger than object number 2, so number 2 would be the original, right? This would be an enlargement because the number is greater than 1. If this is indeed a similar object, we need to do number 1 over 2 again with a different side. Okay, so now I should have put over here, this was side AB, and the corresponding side down here, instead of doing these, it makes more sense. I'll just say we're dealing with 1 and 2 here. And this was side AB. And this was side EF. Now we've got to look at a second side. So we're going to look at the width this time. So on top, we'll put BC. Okay, remember, you got to keep these in the same order. If we're doing number 1 in the numerator, number 1 needs to be in the numerator and the next one too. So we're going to look at BC this time. And then the corresponding for BC is FG. And those numbers, BC is 2.5 centimeters, and FG is 2.4 centimeters. So let's see what 2.5 divided by 2.4 is. 2.5 divided by 2.4 is 1.042 to 3 decimal places. Okay? Not the same scale factor. So what does that mean? Not, number 1, not similar number 2. If it's going to be similar, it has to have both all of the same interior angles, which it does. They're all 90 degrees. But also the proportion or the ratio of lengths for AB and EF, okay, AB over EF equals a scale factor. That's got to be exactly the same for BC divided by FG. And it isn't. It's a little bit different, which means these are not similar. They're similar shapes, like they're the same shape rather. They're both rectangles, but they can't be considered similar rectangles because the proportions are off. So we know that number 1 and 2 aren't the same. So let's maybe have a look now at number 1 and number 3. Okay, so let's look at number 1 and number 3. Okay, it's the same sort of thing. Let's start with the AB, except on this one, AB corresponds to NM. This would be MN, wouldn't it, alphabetically? LMN. So our AB is the same, 8.5, and our MN is 5.25. We're completely ignoring number 2 right now. Sorry, what did I say? 5.25? 5.25, not 2.25. Okay, so this is going to be 5.25. So let's see what this is. And all this does is tell us what the scale factor could be. So we're going to do 8.5 divided by 5.25, and what we get is 1.619. So it doesn't tell us anything yet. It tells us what the scale factor should be if they're similar, but we don't know that they're similar yet. So let's check the other one. So we're going to check, same thing as before, we're going to use BC on our second check, and then BC corresponds to KM here. It could have also corresponded to JN because they're the same, but I'm just pretending that we took rectangle number 1, and then we flipped it, we flipped it 90 degrees clockwise to end up with this shape here and smaller. So BC was 2.5, and then KM is 1.5. So this is going to be 2.5 on top and 1.5 on the bottom, and this was KM. So let's check what the scale factor is here. We've got 2.5 divided by 1.5, and the scale factor is 1.667. Not the same. Boy number. Not the same scale factor. So they are not, or number 1 is not similar to 3. Well, there's only one more to check, so if anything is going to be similar, it's going to have to be number 2 and number 3, because we already proved that number 1 and number 2 are not similar, and we also proved that number 1 and number 3 are not similar. So the only thing left is, are number 2 and number 3 similar? If they're not, then none of these are similar. If they are equal scale factors, that means that number 1's kind of the odd duck out and these two are similar. So let's have a look. So now let's check number 2 and number 3. So now we're going to completely ignore number 1, and we're going to look at E and F. So let's look at EF on top, and then on the bottom, that was MN. So I'm just looking at the numbers up here. So EF was, up a little higher, 8.4 centimeters. And MN was 5.25 centimeters. And 8.4 divided by 5.25 is 1.6. So that's a scale factor. If these are similar, our scale factor would be 1.6, which basically means this would be the original, this would be the enlargement, and this, the number 2 would be 1.6 times as big as number 3. So EF over MN, and then the other thing we wanted to check was going to be the width, which in this case is FG, and then KM again. So FG is 2.4. We got to check FG. And then we're also checking KM. So FG was 2.4 centimeters, and KM is 1.5 centimeters, and we're hoping that this is 1.6. So 2.4 divided by 1.5 is, guess what, 1.6. they check out, which means that because we checked a length, okay, we checked a length and we checked a width. If these are truly rectangles, that means that the same thing is true for Jn and the same thing is true for Jk, because we normally would have to check the sides, all the sides, but because we know that these two sides are equal and these two sides are equal, we only have to check the length and the width. So we checked both the length and the width, and they are both have a scale factor of 1.6, which means number 2 and number 3 are similar. And you can also write that out as, y. Okay, so first off, all interior angles equal 90 degrees. So that was the first thing we needed to check. The second thing we needed to check was proportion of the sides. So what we found was EF over MN is equal to FG over KM. And we didn't actually do the math, but because we know that these are both rectangles, we also know that JK is the same as, is proportional to HG. So this would be JK is proportional to HG, except I got them backwards. You always got to have the same ones on top, right? So, what did I say? This one was JK, right? JK. JK. And now, of course, I forget what the top one was. We did EF, so it must be GH, right? And then the other width, do FG? Did FG? Did GH? Must be EH. So the other one would be EH and JN. So EH over JN. So those should all equal 1.6, and we know they do because we checked them over here. So that's how we can determine that number 2 and number 3, those two rectangles, are similar, and number 1 is not similar to either of them. It can't be, in fact. If number 1 was similar to 3, it would have to be similar to 2. Okay? In this case, number 1 was the odd duck out, and number 2 or 3 are similar. Alright, so example 2 says draw a smaller rectangle that is similar to this triangle. Use a scale factor of 0.1, which means the new one's going to be 10% the size of the original. This is not to scale. If you look at the width and the length, well, 28 centimeters is almost a foot, and clearly it's not going to be a foot tall in this. But essentially, all I want you to do is I want you to use a ruler and try to draw some straight lines, and then using a scale factor of 0.1, figure out and draw this rectangle. So you're going to have to figure out what the width should be, and you have to figure out what the length should be. And that's simple, especially with a number like 0.1. So our scale factor, we know our scale factor is going to equal the original. So this is the original, right? So our scale factor always equals the the new over the original. And now what do we know here? Okay, we know the scale factor is equal to 0.1. What else do we know? Okay, we know that the width is equal to 28 centimeters, and we know that and then we also know that the length is equal to 40 centimeters. So we're just going to use one of those right now, and we're going to plug them in. So when we say SF equals N over O, which are we trying to find out? We're trying to find out the new one. We know what the original is. We don't know what the new one is. So let's just plug in what we have. 0.1 for the scale factor equals N, or I'm just going to call it X because I like solving for X. So equals X over the original. Okay, now let's work with the width first. So the original width is 28 centimeters. Right? So now I've got to find out what X is. Remember, now that we are familiar with what proportions are and how to cross multiply and divide, let's make this easier on ourselves. No matter what the scale factor is, you can always put it over 1. So now we've got that situation where we've got one fraction equals another fraction, And we've got only one thing missing. Remember, you need to have 3 of the 4 pieces of information. So in this case, x is going to equal, okay, remember, cross multiply and divide. So there's the cross. Okay, so it's going to be 28 times 0.1 divide by 1. Well, luckily, dividing by 1 doesn't actually take any effort. So it's going to be 28 times 0.1. So that's 2.8 centimeters. And, we should have done that in our head because it's just 10% of just moving the decimal place, right? So 2.8 centimeters is going to be the width of the new one. And we need to find the length now, right? So we'll do the same thing for the length. Okay. Still the same calculation, the same formula. Scale factor equals the new over the old. Well, I don't know what the new is. I'll just use y. But I do know what the old length is, and it's 40, right? So I should have, instead of putting in SF, I should put in 0.1. And now we know that we can make the proportion. So y is going to equal 40 times 0.1, because that's the cross. And then you divide by the only other number. And then we know that y is going to equal 4 centimeters. Right? We just have to move the decimal place 1 towards the left. So that is going to be the length. So we've not actually drawn anything yet, but we've just used what we know about scale factor to figure out what the new width is going to be and what the new length is going to be. And we know it's going to be a reduction because our scale factor is less than 1. So whatever we're drawing is going to be smaller than the real life version of this. Again, the real life version of this would be, almost a foot in length if you're kind of used to imperial measurements. It'd be about a foot in width, and it'd be, like a foot and a bit in, a foot and a half, say, in length. A foot and a third to be exact. So if I have my measurements, and you will have the same measurements because it tells you what the width and the length are supposed to be, when we get our new version, you should be able to take a ruler, and I'll just take a sort of fake ruler here, and you should be able to redraw this. So I'm going to take this, and I'm going to redraw this shape based on the dimensions that I figured out over here. So my length needs to be 4 centimeters. Okay, I'm going to do my best to draw a reasonably straight line. So it needs to be 2.4 centimeters. So I'm going to take, 4 centimeters. I'm going to take my line tool, and I'm going to start there, and I'm going to go 4 centimeters on my ruler. Okay, and now I have to draw. I have to rotate my ruler. That, and then I have to draw a line that goes straight up. And it has to go, my width has to be, instead of 28 centimeters, it has to be 2.8 centimeters. So I'm going to take my line again, start there, right at the end. And then I got to go up 2.4 centimeters, which is right there. Okay, and then I can do the same thing over again for the other sides. So I'll just kind of do this one backwards. I'll start at 4, go back to 0. So straight line from there, back to there. And then the last one, I don't need the ruler at all. Leave the ruler because I'm just joining up here. Okay, it looks like I missed by just a little bit, so I'll just down there, move it a touch. Yeah, that's pretty good. So this new shape is 2.8 centimeters here and is 4 centimeters here based on the ruler that I used. So this would be the new one. Okay? So the new one is a reduction of the old one. Reduction, and the scale factor is 0.1. Again, the original is not drawn to scale properly because it's on a piece of paper and it's supposed to be over a foot long. But if they gave us the information on what the dimensions are supposed to be, the length and the width, and they gave us a scale factor, we have enough information to both find out and draw the new version. B is another example. So this one, instead of a square, it's a pentagon. And this is, looks like home plate if you're into baseball. So this would be 90 degrees. That's what that little square means. 90 degrees, 90 degrees, 90 degrees, and then 135 and 135. So if we're going to draw a new version of this, that's a scale factor of 2. That means it's going to be twice as big as the original. This is not drawn to scale. Okay, this is not drawn to scale. But we are going to figure out what each of these sides should be. Okay, and then we're going to draw a new one. So let's look at same process, exact same. It's just there's 5 sides now instead of 4. So our scale factor is going to be equal to, as always, our new over our old. And what do we know? Our scale factor is 2. Okay, and we've got all sorts of lengths. So let's just use 2 for now. Okay, let's look at CD is equal to 2.8 because that's the same as BC. I guess I could say that. Then I've got BA, or AB, is equal to 2, which is also the same as DE. And then I've got one more side, that's AE, which is equal to 4 centimeters. And that's the only one that's 4 centimeters. Okay? Well, we should put the units in there, but I won't for now because I didn't put the others. So using that information, we can figure out our new sides. And we already know the angles are all going to be the same. So let's look at, instead of CD, let's look at finding C prime, D prime, which would be the new one. So our scale factor, let's just sub in what we know. Scale factor is 2. Our new is going to be, say, X. Our old is the 2.8. As always, we can take our scale factor, put it over 1. Now we've got a proportion. So this is for side C prime, D prime, which is basically going to be this side on the new object. So what is this? Let's cross multiply and divide. So it's 2.8 times 2, divide by 1. So 2.8 times 2. And then divide by 1 doesn't change anything. So it's going to be 5.6 centimeters. So that's going to be CD prime. And because remember, CD was the same as BC. Okay, so that's going to also be B prime, C prime. So we figured that part out. Okay, now let's move on to the next one. Same thing. Scale factor is 2. Let's use Y this time, just so we can kind of keep them separate. And so Y is going to be the new one. And then we're going to look at DE and AB on this one. Okay, so let's look at what is the original for AB and DE. It is 2. Okay, so let's cross multiply and then divide. So that's going to be 2 times 2 is 4. Divide by 1 is 4. So it's going to be 4 centimeters. Okay. So this is going to, this is, I'll just move this down just a little bit. We did CD and C prime, D prime, and B prime, C prime. This was D prime, E prime, and A prime, and A prime, B prime. So that's this side and this side, and we said that was 2 over 1 equals Y over 2 equals 4 centimeters. And the only other thing we need to figure out is the bottom part. So that's going to be A prime, E prime. So we know our scale factor is still 2. And then this time maybe we'll use, what am I going to use? Z. I don't like using Z because it looks too much like 2. I'm going to use W. So this is going to be W over 4 because the original is 4. And, this is AE prime. Keep forgetting to label it. A prime, E prime is the bottom part. So scale factor is 2. I said we're going to use W, and it's going to be 4 centimeters is the original. So on the new version, it's going to be, right, cross multiply. So 4 times 2 is 8. So it's going to be, and divide by 1 is just 8.0 centimeters. So we've got all the dimensions for our new one. This is going to be 5.6, 5.6. This is going to be 4, 4, and this is going to be 8. So let's draw it with that fake ruler of mine. Hopefully you can get it big enough. Here's the fake ruler. Oops. Put my fake ruler down. Let's see if I've got enough room to do it here. I need 8 centimeters. Yep, should be lots of room. Okay, so let's start with the bottom. And I'll just draw a line. That is 8 centimeters. Okay, so that takes care of the bottom there. I'm also going to mark the center point because I'm going to mark the center point in a different color. And the reason I'm doing that is because I need to know where to join up the peak of this thing. It needs to be right in the middle of the object. So you can ignore this line. It is just for lining up It is just for lining things up. Okay. Move that over just a touch. Okay, so that is 8 centimeters. Get rid of that guy. Need that. Okay, so this is the bottom is 8 centimeters, and then we've got to go straight up DE. Well, what was D prime, E prime? It's 4 centimeters, so let's just rotate my ruler. Obviously, it's going to take less time to draw than me, because I'm kind of having to play with it in a digital manner here. So I'm going to take my line tool, and then I'm going to draw up 4, what did I say, 4 centimeters? Sure, 4 centimeters should be right there. Okay, and then I'm going to do the exact same thing on the other side. So to make it easy on myself, I'm just going to copy this. Paste it. I know it's the same. Put it in the same spot. And then I know I need to join to the join to this line, a line that is 2.8 centimeters. And I also need it to be 135 degrees. So here's the dealio. You need to find a protractor. And hopefully you got something that looks like this. Because from here, we need the angle to be, what did I say, 135? Angle needs to be 135 degrees. All right. Okay, so if this is 100 degrees going straight up, then from here to get to 135, I need to go a 45 degree angle, which is right there. So what I'm going to do, so this is kind of getting into drafting territory here. What I'm going to do is, first off, just make sure I'm bang on. And now what I'm going to do is I'm going to create another red line just to kind of help me find out where I need to meet the middle piece. It has to be exactly 45 degrees from here. So 45 degrees from here, sorry, this is 90, so 45 degrees would be right in the middle, right there. Okay, now I'll show you why I did this. Okay, so I'm just going to get rid of this because I don't need it anymore. I'm going to get rid of my ruler because I don't need it anymore. Okay, now I made this line a little short, so I got to make it a little taller and still straight up and down. See where this crosses? That has to be where my black line is going to go. So I'm going to go back to black, and then I'm going to start from here, and then I'm going to go at 45 degree angle to wherever this crosses. So that's why I drew that red line, is just to find out where this thing needs to meet. So there's my one line, and then the other line obviously goes from the exact same place down to the other side. Now, I probably didn't draw this 100% perfectly because I'm using the mouse, and it's probably a little bit off. But it shouldn't be much. So I'm going to, lock this in place. What I'm going to do is I'm going to grab these lines. Hopefully, let's grab more than one. And move this down. This again was just the mark that showed me where I needed to cross it to. Now, this should be a good representation of our scale factor. So this was 8 centimeters. This was 4 centimeters. And we didn't measure this, but we said it should be 5.6 centimeters. Now, again, I did draw this using a mouse, and I did the best I could using some drafting techniques, but it may not be perfect. So when I check the final size, although I'm hoping that the length here is going to be 5.6, it might not be exact. So let's just have a look when I rotate my ruler. So you can rotate it 45 degree angle. Not sure what that is. I guess we'll find out. Hard to rotate. Something like that. Okay, let's see what this is. 5.6. Ooh, 5.6 right on the nose. Okay, good. So my drafting technique worked reasonably well. And we managed to make this new version. Okay, so this is the new version. And the scale, so this would be an enlargement, right? Because the original is smaller. This would be an enlargement with scale factor of 2.0. And because this is a, what you would call it, a symmetrical object, the other side is the exact same. Okay, so the whole point of this unit is if you know what the scale factor is and they give you measurements on an original, you can come up with an enlargement or a reduction on your own. They can also give you two shapes with some measurements, and you can determine are they similar or not. And you can just sort of fill in the blanks on missing angles and missing sides between two similar objects. So as long as you can figure out how to get to this point where you use the formula to get to a ratio, then if you can remember the cross, multiply, and divide, you can do these very quickly, and you can also check your answers very quickly. So best of luck with that, and as always, send us questions, concerns. If you have trouble with anything, via email, and we'll do our best to help you out. Have a good day.